Hi students, so from today onwards we will start the chapter waves. So what I am going to do is first I am going to give you a brief synopsis. It may be brief, but I'll try to tell you all the details which are important for your entrance exams. Okay, so I'll be discussing the synopsis of waves chapter, and after that in later videos I will solve as many important multiple choice questions as possible. So please subscribe to the channel so that you can see the other videos. Okay, so let us start. So when we say waves, what comes in your mind? So ripples in the water, right? So if you consider water surface, okay, it is calm right now, okay, no disturbance. Now if you put a ball in one of the place in the surface of water which is floating, and then you disturb the water at one point, then as you keep disturbing the water at one point, as you wait, you will see the ball is also getting disturbed. So whatever oscillations occurred here, whatever disturbance occurred here is slowly getting transferred to the ball. Through what? Through the surface of the water. So this kind of propagation of disturbance, okay, from one place to another place without transferring any matter. The water did not go as a whole. If water went there, then what will be here? No, nothing cannot be there, right? So when you disturb a certain part of the medium which has elasticity and inertia, these two words are important, okay, elasticity and inertia, then there can be waves in the medium. Now waves which require this medium like ripples of water, sound, string waves, they are called mechanical waves. Then we have also non-mechanical waves in which uh, medium is not required. So the obvious question is, what is oscillating? It cannot be a vacuum, right? Because vacuum means nothing. So what is oscillating in a non-mechanical way? Well, in later chapters in second PU, you will learn about electric charge and field. Okay, so if there is a charge in a certain space, okay, then when the charge is at rest, then it creates a electrostatic field around it. Field is basically region where this charge can exert its effect. Okay, so when this charge is at rest, the electrostatic field around it is also static. Okay, it has a certain fixed value in magnitude and direction. When the charge will oscillate, this field starts oscillating. This field also starts changing, and that changes propagate through empty space. And that changes is this changes in electric field. And later, as you study more, you will come to know that there is a magnetic field also. So this changes in electric field and magnetic field is what results in non-mechanical waves to travel from one place to another place. And light is a example of non-mechanical wave. That's why we call it electromagnetic waves. Okay, so we have mechanical waves, we have non-mechanical waves, then we have also something called matter waves. Okay, so matter waves are something which cannot be understood through the classical physics. Classical physics means the physics made mainly by Newton. Okay, so for that you have to study in second PU. There is a chapter called dual nature. So there you will come to learn about matter waves. Okay, so do not confuse matter waves with mechanical waves. They are completely different. So if you are still wondering what is oscillating in a matter wave, because in every wave something should oscillate, something should disturb, because that propagation of disturbance itself is called waves, right? So in matter waves, what actually changes from place to place is the probability of finding any given particle. So that probability distribution is what we call as matter wave for a single particle, mind you. Okay, so keep that in mind. So, so a wave can be mechanical, non-mechanical, or it can be matter waves. Okay. Now we are interested in how to describe waves mathematically. Okay. So we will start with a very simple wave, which is called harmonic wave. So harmonic wave means the particles in the medium are performing simple harmonic motion. Okay, and the mathematical way of representing a harmonic wave is the displacement of any given particle which is at some location which we will write x from the origin. Okay, at a certain time t is given by the formula a sine kx plus minus omega t plus some constant called phi. So let us see what are the characters here. Okay, first understand what is this phi. So let us take a simple example. Let's say a string is there, and this other end is very far. Okay, why I am calling that other end very far is there's a reason for that. Later you will come to know. Okay, so let's say I make this particle go up and down, simple harmonically. So this particle is performing SH, and let me call that particle as x equal to 0. Then this line can be called your x-axis, right? Now I want to know displacement of not only this particle. I want to know displacement of this particle, this particle, this particle, this particle, all the particles at any given time. Okay, so I need a function, mathematical function, which will give me displacement while this is along y-axis. Okay, of a given particle which is at a distance x, okay, this x at a time t. Okay, so that formula is given by this. Now a is, what is a? Obviously the maximum value of sine is 1. So a is the amplitude of the displacement for the given particle. This x is the coordinate of that particle. K is called wave number. It is given by 2 pi by lambda, where lambda is the wavelength of the wave. And omega is given by 2 pi by time period. Okay, so omega is called angular frequency because 1 by time period is called what? 1 by time period is called frequency. And frequency determines what? Number of oscillations per second. Right? Similarly, this lambda, see, this I can write 1 by, see, this 1 by lambda. See, 1 by capital T here plays the role of 1 by lambda. So this 1 by lambda is also called number of waves per meter, or you can say number of oscillations also, no problem. But per meter it is. Okay, this is per second. This is 1 by t. This is 1 by lambda. Okay, so k is called your angular wave number. Why? Because it determines how many waves are there per meter. This determines how many waves are there per second. Okay, fine. Now, suppose you imagine there is a string like this. Okay, now let us say I move this end up and down. So let's see how the shape of the waveform. See, when you know displacement of each particle, you will be able to draw the shape of this string. Okay, that shape is what is called waveform. Okay, waveform. So let us see how the waveform changes as you oscillate this particle. So let's say at time 0 this particle is here. Now when I take this up slightly, the next shape will be like this. Okay. Then because of tension between the parts, this is pulled up, right? So this will try to pull this up, right? So this will go up. By that time your hand will come down, right? So the next shape will be like this, right? Then this will pull this one up. So initially it was like this, right? At time 0. Then you did it like this, right? Up. It looks like this, okay? Then when you bring it down, this part will pull this one up. Then this will pull this one up. By that time your hand will go below this mean position, right? So it will go somewhere here. So your wave will look like this. Next moment this will go this side. So let me show you here. So this part will go this side. And your hand will come back here, right? So basically the wave will look like this. Now if you keep doing this up and down, then very soon you will see a chain of waves being produced. Okay. So see, this is time 0. So this particle was here, right? It went up here, then came down here, then went further down here, then came back here. That means from here to here, it took one time period. Right? Time period means what? From here to here to here. So during this time period, the disturbance here has traveled here, right? And this distance is what is called wavelength. Okay, is it visible? Yeah, wavelength. Okay, that means the wave velocity v. The wave velocity. I'm not talking about the velocity of the particle. That you can find by taking differentiation of displacement of the particle with respect to time. So if you want particle velocity, you have to do dy by dt. I'm not talking about this. I'm talking about the speed with which the disturbance is moving. So that speed will be given by the formula. Distance covered is lambda. In what time? Time period t. Right? You have seen there. And 1 by time period is called frequency. So velocity is frequency into wavelength. Now, can I write velocity in terms of omega and k? Yes, I can also write same velocity as omega by k. Okay. Check once. Omega is what? 2 pi f. So omega is 2 pi f, right? K is what? 2 pi by lambda. So 2 pi will cancel, lambda will go up, same formula you will get. Fine. So K is called wave number, omega is called angular frequency, or actually K is called angular wave number, omega is called angular frequency. When you divide omega by K, you get the wave velocity, which is not the particle velocity. Please see the difference, okay? And phi is basically the initial phase. So phi is initial phase, okay? Initial phase, because this whole argument is called phase in physics, okay? This you have understood this in the previous chapter, which is called simple harmonic motion. So this is the initial phase of x equal to 0 particle at t equal to 0. Why? Put x equal to 0 and t equal to 0. What will this phase become? Phi, right? So phi is the phase of particle at x equal to 0 at time t equal to 0. So this is the mathematical way of representing a wave. So a simple question that can be asked in CET and NEET exam is, so they will tell you that the wave is given by 5 sine 100x plus. Okay, I did not speak about this plus and minus, right? So let me to quickly tell you, minus means the wave is traveling along positive x-axis, and plus means the wave is traveling along negative x-axis. Okay, so these two. Minus means what? The wave is traveling along positive x-axis. Plus means it means it's moving along negative x-axis. See, I don't want to derive all that relation. Otherwise, the video will become too long. And I just want to give you the synopsis for your upcoming NEET exams and CET exams and JEE second exam. Okay. So suppose 5 sine 100x plus, and suppose I write 5t like this, and then I ask you the wave velocity. So how will you find? Directly see. First understand something, okay? This y, sine has no unit, right? So y and 5 should have same unit. So if y is in meter, 5 will be also in meter. Okay? But x should have unit of whatever. See, if x is in meter, then this 100 will be per meter, because this should have no dimension. Understood or not? So if x is in meter, 100 should be in per meter. But if x is in centimeter, then 100 is in per centimeter. And t is in seconds, so 5 will be in per second. So the second will cancel. So what is the wave velocity in this problem? So wave velocity will be omega by k. Omega is this one, 5 per second, and k is 100 per centimeter. Okay, so this will be 0.05 centimeter per second. So it is doubling very slowly. Okay, if I had given if x was in meter, see, it doesn't matter what is y. Okay, y will control the unit of this value. But if x is in centimeter, 100 will be in per centimeter. If x is in meter, then this 5 when you write this 100 when you write here, you have to write per meter. Then the answer will come meter per second. And if they ask amplitude, obviously amplitude will be this 5. So 5, if this is in meter, answer is meter. Okay. Then if they want frequency, then you know that this omega is 5 and omega is 2 pi frequency. So equate 2 pi f with 5. Then frequency will be 5 by 2 pi. That way you can calculate everything about the wave once you know this equation. Okay. So once we have understood this kind of wave, which is called traveling wave, because the disturbance moves from one place to another place, let us see what happens when waves, more than one waves overlap. So one very important difference between waves and particles is, at least in classical physics, is uh, waves can overlap, okay, whereas particles cannot overlap, right? If you have two potatoes, you will never be able to overlap them and get a big potato. and you will never be able to overlap them and suddenly vanish the potatoes. Okay, but in waves it can happen. Okay, so imagine let us talk about now superposition of waves. Superposition of waves. Okay, so imagine I have a string like this, like the previous one, and this time instead of creating a chain of waves, a continuous traveling waves, let me create a pulse like this. So I create a pulse like this here, and you create a pulse like this here. Okay. So as discussed before, this pulse will travel with some wave velocity, which we have discussed, and as they meet, when they reach here, it will look like this. So if this is amplitude A, this is amplitude A, this will have amplitude 2A. So this is the meaning that the waves can overlap. Okay, so right now you can see only one pulse. And later as they continue, this wave, which is 1, 2, this wave will continue as 1. As nothing happened here, as if nothing happened. Okay, and 2 will continue as 2. So this is something very interesting. Okay, so this can never happen with matter, right? You don't meet another person and then overlap and then go through it like as if nothing happened. But this can happen in waves, and we are lucky that it happens, right? That's why when music, when in a room when music is going on, okay, in some birthday party, let's say. So here music is going on, and here you and your friend are chatting. So from music, some song is coming, right? Kal ho na ho something, and you are talking, how are you? So that kal ho na ho and how are you will not mix, and it will not be ka ho no, how are you, like something mixture will not go. Okay, so you will be able to hear what your friend is saying. The words will, how are you, that how will go as how itself. It will not overlap here and then change, and that change thing doesn't go in your ear. Okay, so it overlaps, but then it goes through as if nothing has happened. So that is the beauty of superposition of waves. In the same way, if this wave pulse was like this, okay, then when they meet here, this is A, this will be minus A. Okay, the displacement is vector, right? So when they superimpose here, for some time there will be no disturbance when these two will meet here. And then the first one will continue as if nothing has happened, and second one will continue as if nothing has happened. So this is one of the most important thing which you never find in particles, in classical physics at least. Okay. Later in quantum mechanics, where we treat particles as waves, we will see the difference. So I hope you understood this. Okay. So this is the whole idea of superposition of waves. So when you want to find displacement of a given particle, like here, when two waves superimpose, that time the resultant displacement is given by the vector sum of the individual displacements. Okay, it's a vector sum. So if they are in same direction, you have to add. If they're in opposite direction, you have to subtract. So that's why we call this algebraic displacement. Now, based on this superposition, you have uh, three kinds of superposition. The first one is two waves, identical waves, travel in the same direction and they overlap, but they have a phase difference. So there is a phase difference. Okay, so I was talking about phase difference before, right? It's basically phase, right? It determines the state of vibration. So when we write y equal to, let's say simple, okay, y equal to a sine omega t, that omega t determines the state of the vibration. Why? Suppose omega t is 0 degree, then y will be what? A sine 0. Matlab y will be 0. So displacement 0 means where is the particle at mean position. If you take derivative, you'll get velocity. From velocity, you will find whether the direction is positive or negative. So by knowing that angle, you know where the particle is and where it is going to go. Matlab, in physical terms, you will know its position, where it is from mean position, and you will know its direction, where it is going. Once you know where it is and where it is going to go, you know everything about the particle, right? That's the whole idea of physics, right? When we had s equal to ut plus half at squared. What is the point? If you know initial velocity and initial position, using this formula, you can find the displacement. Matlab, you can find where the particle will be after some time. So once you know position and its direction of motion, velocity, then you know the state of the particle. Okay, and once you know the present state, you can use equations of physics or laws of physics to determine the future of the particle. Okay, So, so when two waves are traveling in the same direction, identical waves, everything is same, let us assume. It may not be necessary, okay? One may have amplitude A1, other may have amplitude A2. So when there is a phase difference and when they overlap, then what happens? We consider this as interference. Okay? Interference. Similarly, in the second part, if two waves, identical waves, are traveling in opposite direction, and if they overlap, then you get something called standing waves. And then, if you have two waves traveling in same direction, okay, no phase difference this time, but there is a difference in the frequency. One is omega 1 angular frequency, other is omega 2. Then you get something called beats. So these three things we need to discuss quickly as under the topic of superposition of waves. So let's say you have two waves which are given by the formula y1 equal to a1 sine omega t plus kx, let's say, or minus kx. This is traveling along positive x direction. Okay, you can write this as kx minus omega t or omega t minus kx. That is not a big deal. Okay, that's because this is sine function, right? So sine, you know, with time, if you keep waiting, this angle one day will become such that sine will become negative also. So I can always interchange this and one minus sign will come here, right? So do not take this plus sign very seriously here, because sign, you know, can be positive also, negative also. So you can always interchange this. Fine. So now this wave is one wave, and the other one is not identical in terms of amplitude is not same, but I am keeping the frequency omega and the wave number which is related to wavelength same, but there is a some phase difference. Okay, there is a some phase difference. Then they may ask you to find the resultant amplitude. Now, if you add these two and use trigonometry, it will take lot of time. Okay, because I may give you three functions. I may give you one more wave. Then what will you do? Sine A plus sine B, you know. What about sine A plus sine B plus sine C? How will you do that? It will become very lengthy if you start doing it using trigonometry, right? So we will use something called phasor technique. So in phasor technique, what we do, we represent each wave by an arrow. The length of the arrow will give you the amplitude, and the angle the arrow makes will give you the phase. Because mathematically speaking, this must be angle, right? After sine, what will come? After sine, no, sine of 45 kg, nobody asks, right? Sine of 45 degree makes sense. So after this, this is called phase, right? So you can see, let me assume this is zero phase. Okay, let me assume this is zero phase. So let's say this is some reference line. So whatever angle this arrow will make with some reference line, that angle is called the phase. Okay. So again, let me repeat. So if you are given a particular wave, using phasor technique, how to add these two waves is treat each wave as a phasor, which basically means an arrow, such that the length of the arrow gives you the amplitude, and the angle this arrow makes with some fixed line, which is reference line, gives you the phase. So if I assume this displacement, particular wave, is represented by this arrow, and it makes zero angle with the reference, then I am assuming this is 0. Then what will be the phase of this? 0 plus 5. So 5 will be the phase. So second wave, how will you represent using this arrow? You will represent it somewhere here, right? So the length will be A2, and the angle this arrow will make with this arrow will be the phase difference. So now to add these two is super easy, right? Because you know vector algebra. So just draw this diagonal, then draw the parallelogram, then draw the diagonal. So this will give you the resultant amplitude, AR. So what will be your resultant amplitude? From the formula which you know, root over A1 square plus A2 square plus 2A1 A2 cos of phi. Only thing you have to remember is phi is not the angle between two vectors as such, but it represents the phase difference between two waves. That you should remember. Now, if someone is interested in not amplitude but intensity, let's say intensity, then how is intensity related to amplitude? Intensity of any wave is always proportional to square of the amplitude of the wave. The square makes sense also, right? So see, amplitude can be positive, can be negative, but intensity has to be positive because intensity represents loudness. In case of sound, it represents loudness. In case of light, it represents brightness. And brightness and loudness cannot be less than zero, cannot be negative, right? How can you produce less sound than no sound? Less sound, no sound means zero intensity, right? You cannot have less than zero sound. But amplitude can be positive or negative depending on the direction of its oscillation. So if that square is important so that intensity remains positive all the time. That is how I used to remember, and I hope you all can remember the same way. So if I square both the sides, what will I get? AR square equals to, let me do it here itself, right? So AR square will be, the root will go. So if I remove the root, then I can write square here. Right? Then you know intensity is proportional to square of amplitude. So it will be equal to some constant k, let's say. So I can multiply that k both sides, right? Here, 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 and right here. Okay. Then this will be what? This will be resultant intensity from this formula because this is resultant amplitude square. This will be what? Intensity of the first wave, intensity of the second wave. Now this k I can write as root k1, root k2, root k, sorry. So what will be, if I take root both sides, what will I get? Root I equals to root k a, right? Okay. So this root k a1, root k a is root I. So root k a1, I can write root I1. Root k a2, I can write root I2 times cos. So this is the formula to find the resultant intensity. Okay. Now, what will be the maximum intensity? Will be maximum when cos phi is 1, right? So when cos phi is 1, intensity IR will be maximum. And if this is 1, then if this is 1, then we will get this formula. And that is nothing but root I1 plus root I2 whole square. Right? That is your maximum intensity, right? Because this is root. If I write root I1 plus root I2 whole square and I then open the bracket, I will get this only, right? A square plus B square plus 2AB. Similarly, when will the intensity be minimum? When this cos phi, which was here, is minus 1. So there is a minimum value this can have, right? Cos phi has minimum value minus 1. So then the formula will become, this is, yeah. So IR minimum will be root I1 minus root I2 whole square. So if they want the ratio, you can just divide this two. Okay, so I1. Okay. So try to remember this formula. So one of my student had asked a problem based on this question. Let me just discuss the problem. Okay. So you can make a note if you want. Okay, let me dictate. Three waves of same intensity. Three waves of same intensity I naught having initial phase 0, pi by 4, comma pi by 4. So there are three waves, each having intensity I naught. So if intensity is same, amplitude must be same. Okay. And they have an initial phase of 0, pi by 4. Pi by 4 means 45 degree. Am I right? 180 by 4, yes. 45 degree respectively. They interfere at a point. So these three waves interfere at a point. Question is, find the resultant intensity. So again, see, let us say the amplitude for each wave is A naught. A naught they have not mentioned. Option will be in terms of I naught only, right? But let us write in terms of A naught because we know phasor, when we apply phasor technique, the length of the arrow represents the amplitude. So this first wave, let's say, has this arrow. The length gives you the amplitude. And the first arrow makes what angle with the reference line? They have given 0. Now other one makes what phase? Pi by 4. So pi by 4 means 45 degree here. That is also A naught. Second one is pi by 4 with this one. Okay. So that is that they should have mentioned. Okay. So other one is this first one has phase pi 0. second one has phase pi by 4. If third one also has pi by 4, then it will be here itself. But I don't think that is what they want. Okay, so there is a mistake in the framing of the question. The third wave should have been mentioned as has a phase of pi by 4 with respect to this wave. So third wave will be here. Okay. So these three waves are interfering at a point, and they want the resultant intensity. To find intensity, always try to find amplitude first. So one first wave has this amplitude making 0 angle. Second wave has this amplitude same, angle is pi by 4 with respect to this. So this is pi by 4, 45 degree. Third one is amplitude is A naught only, length is same, but it makes pi by 4 with the second one that they have not mentioned. Okay, so actually speaking, as per the question, if I do, this arrow should be here itself. Then it becomes very easy. I'll show you that also. But I'm sure they wanted it to be here. Then how to add these three arrows? Then bring your vectors knowledge. So let us find x component of the resultant. So this is along x. Let us call this x, this y. This is not along this is along y, so this will have no component here, right? This is at 45 degrees, so it will be plus a naught cos 45. So what is this component of this a naught in this direction? So this will become a naught 1 plus cos 45 is 1 by root 2. So this will be a naught root 2 plus 1 by root 2. So that is the total amplitude along x, one component basically. What would be the other component ay? It will be exactly same, a naught root 2 plus 1 by root 2. Why it will be same? Try to think. This arrow is along y-axis. This arrow will have a component here, a naught cos 45, right? Because this is also 45. So that will add with this, giving you the same answer. So the total amplitude AR will be root of, when you know x component and y component, what do? You add the squares of the components and then take the square. See, all this you have to learn in vectors. That will be equal to root of square this one, so it will become a naught square, right? Root 2 plus 1, root 2 square will be 2 plus and twice of this because it's the same thing. Right? So I square this, then I multiply by 2 because I am adding ax square plus ay square, which is basically same. So or I can do this way also, right? Look here, if you are confused. I know from the values which I calculated, ax and ay are same. So imagine this is also ax. So this will become root 2 ax. So this root 2. So when you substitute this a naught here, a naught, this is ax, sorry. When you substitute this ax here, root 2 and this root 2 will cancel. So it will become a naught root 2 plus 1. So I have calculated the resultant amplitude to be equal to a naught root 2 plus 1. But they wanted you to find intensity. Well, what's the big deal? Square both the sides. So if you square both the sides, this AR square will be your intensity which they want. A naught square will be the given intensity, and this will be root 2 plus 1, 1.4, 1.4, okay, plus 1, 2.4 square. And whatever is the answer that you can take. Okay. What if I do the problem as per the question? So as per the question, if I do the problem, you can pause the video and make it work, right? So as per the question, if I do, the first wave is A naught at 0 phase or 0 angle. Second one is pi by 4. Pi by 4. Third one also is pi by 4. So then it will become, these two will give you 2A2. With these two in the same direction, so I can simply add. Then I am left with this A naught. And this is 45 degree. Then you can write AR equals to root of this square plus 2 this into cos 45. So that way the answer will come very easy. So in the next video we will discuss about the other two topics, which are standing waves and DITs. Okay. Thank you.